Okay, let's wait for this. Meanwhile, let me know in the chat how was the contest. Did you like the problems? Also, like if I'm audible properly or not. Like let me know about these things. Okay. Hello. So how was the contest overall? Like, did you like the problems? Were they easy? Did you face any difficulties? Audible was lucky, unlucky. Today's corner couldn't solve any. Usually solve. Wasn't able to solve any. Okay. That's not a problem. Like maybe a bad day. That's totally fine. Like we'll discuss the solutions. So I think that should help somehow. Let me get my writing pad quickly. It's good I solved every problem. That's good. Constraints are wrong for third question. I guess we'll try to see that. Okay. Cool. Okay, let's start with the first problem. So again, for me, like I would say I have seen the questions, the problems. The third question was a bit tricky. I would understand. It was very observation based, and the first and the second questions were pretty straightforward. So yeah, but anyways, let's discuss the solutions. So I think that should make things more clear, right? So the first problem is minimum number. So the question states that you are given an array ARR of n elements. In one operation, you can pick two indices I and j such that ARR I is greater than equal to ARR j, and replace the value of ARR I with ARR I minus ARR j. You have to minimize the maximum number of array minimize the maximum number of the array after performing any number of such operations, right? So in any operation, what we are doing, in any operation, we are taking two elements I and j, and we are doing ARR I minus ARR j, right? ARR j, we are replacing the value of ARR I with ARR I minus ARR j. Is the mouse move? That's weird. Okay. Oh, because of this. Got it. Sorry. So you have to minimize the maximum number of array after performing any such operations, right? So you had given n elements. You are given an array of n elements, and in each operation you take two elements I and j, and you replace ARR I with ARR I minus ARR of j, right? And you do this as many times as you want. You have to minimize the maximum number in the array after performing any number of such operations, right? So for example, 3 to 4 is there. So 3 to 4, what we are doing? First of all, we can take 3 and 4. 3 and 4, if we subtract, it will be left with 3, 2, 1, because 4 minus 3 will be 1. And after that, we can take 2 and 3, so it will left with 1, 2, 1. And then 1, 2 and 3 maybe, so it will be 1, 1, 1. So eventually it will be left with all the elements like something like 0, 0, 0, 0, 1 or 1, 1, 1, something like that, right? So that is so it will become 1 will be the minimum value for the maximum number, right? We cannot go less than 1. Okay. Similarly for 2, 4, first of all we'll take 2 and 4, we'll subtract, so it will become 2, 2. Then we'll take 1, 2 and subtract other one, it will become 2, 0, and then we cannot make any moves, so it will become 2, 0. So the answer will be 2, right? Okay. So okay, recursion is passing. Maybe weak test cases. I am not sure. I haven't stress tested it, so I cannot tell. But yeah, like recursion should not pass ideally. But if it is passing, then you are lucky. So okay, so let's understand this, right? So what we are doing? Let's understand what we are doing. We are taking two elements A and B. Okay, let's just focus on two elements as of now, right? So let's just focus on two elements as of now, A and B. What are we doing? We are doing A minus B, and let's assume A is greater than B, right? Definitely if A is less than B and we do A minus B, this doesn't make sense, because this will become a negative number, and after that if you cannot use it to subtract from something else, right? So it's always better to keep them positive and get them as lower as possible, right? And later on we might think about transferring it to negative, but again, like once it becomes negative, you lose the power, like you cannot use this element anymore. Let's say it becomes -1, right? Now let's say you have an element 2. If you subtract -1 from this, it will add 1 to this, right? It will become 3 then. So this -1 cannot be used anymore, right? So it's always better for us to keep it positive. So a is greater than b, we are doing a minus b, and we do a minus b couple of times, right? How many times do we do this, and what is this called? What is this called? Doing a minus b multiple times. So we have 6, we have 2, we are doing 6 minus 2 multiple, or we have 7, we have 2, we are doing 7 minus 2 multiple times. So 7 minus 2, it becomes 5, 5 minus 2, 3, 3 minus 2, 1, we stop at 1. So this is basically, essentially this is division, right? This is division, and we stop at the remainder. So a minus b multiple times, as long as it is possible, we do it as long as a is greater than b. This is called division. B is dividing a. B is dividing a, and the remainder is a modulo b. We stop at the remainder a modulo b. Right? Okay. So now, let's say we are given two numbers. Right? We are given two numbers, and we know that we'll divide them. Right? So let's call this method f. Let's call a method f. F takes two integers, and it will reduce a and b to the lowest form possible. It will reduce a and b to the lowest form possible, right? Let's say we take f, it will reduce a and b to the lowest form possible, right? Now what we are doing, let's say a is greater than b. Initially, let's assume that a is greater than b. So first of all, we subtract b from a as many times as we want. So basically we do b by a. A is reduced to, it is, what is it reduced to eventually? It is reduced to a modulo b. This is reduced to a modulo b. What is the property of a modulo b? Remainder should be less than b. Remainder should be less than b, otherwise it could have been divided again, or it could have been subtracted again. So remainder is a modulo b, it should be less than b. So after this, we reverse, right? We call now with the remainder, we try to reduce b as much as possible. So now b becomes the first element and the remainder becomes the second element, right? We call fbr again. So what does, again, let's write it down in a simpler fashion. There is a function ab that is calling f b comma a modulo b. Is there any function that rings the bell here? Is there anything that is like synonymous to this function, or you have seen this function before? It is, right? It is the GCD. It is the Euler's GCD method, computation method. Like GCD of AB, what do we tell? GCD of AB is GCD of B, A modulo B, right? And exactly that is exactly what's happening, right? This is exactly what's happening. So GCD AB, we are calling from GCD AB, we are also calling GCD B, A modulo B. So basically, two numbers A, B will be reduced to GCD, like GCD comma 0 or something like this. This is what they can be reduced to finally, right? So two numbers A, B can be reduced to GCD comma 0. Now we have n numbers with us, right? We have n numbers. Let's actually increase this to 3 numbers, A, B, C, and understand what exactly happens. So A, B reduces to GCD. Let's call it G. G equals to the GCD of A, B. Okay. Now we have G and C left, and one of the elements has become 0, right? One of the elements has become 0, so we do not take this. Okay, GC, again we form the same thing. So we do the same thing again, 2 elements, we do the same thing. So it will get reduced to the GCD of GC. What is the GCD of GC? It is basically the GCD of AB and C. That is, it is the GCD of ABC. So 3 numbers are reduced to GCD of them. Similarly, n numbers you can add, keep on adding numbers like this. So n numbers, for n numbers we can generalize this. N numbers will be reduced to, so A1, A2, we have n numbers, AN. It is reduced to GCD of what? A1, A2, N. So all of them are reduced to GCD, right? So the final element will be GCD and everything else will be 0. We can reduce the entire array to this thing. So the answer of our question will be the GCD. Nothing else, right? We want the minimum possible value of the maximum element. What is the maximum element? GCD G. So what is G? GCD. So you have to find the GCD. That's the question. Does this make sense? Any doubts? Any doubts with this? Any doubts with how we landed with GCD? Let me know if you have any doubts with how we are landing with GCD. GCD of what numbers? The array elements, right? The array elements. Sorry. We are given n numbers, right? We are given n numbers. We have to like subtract. We have to take two elements, and in each move we subtract ARR I minus equals to ARR J. No, you can do it in multiple ways. That is also working because again, like it is also given that ARR it's always better to like reduce with the minimum element. That's also one logic. But again, like it eventually reduces down to GCD only. So we'll get with the final solution should be GCD. You can do it with maxif as well. But again, like if the constraints are made proper, maxif would take around order of n log n. But with GCD you can do it in order. That's also in log n actually. So yeah, like it doesn't matter. What is the intuition of using GCD? Okay, let's understand this again, right? Let's once again repeat this thing. I guess many of you have missed. So let's just repeat this, and this is the last time I'm repeating this. So like just hear it carefully. Let's just focus on two numbers, right? Let's just focus on two numbers, and we are doing this. Okay, so let's just focus on two numbers, and we will lower index. We can only subtract the lower index, lower value number from higher index, higher value number. Sorry, there was a constraint. There is no constraint with I and j. It is only that ARR is greater than equal to ARR j. Only then you can subtract. So basically it tells you to keep positive, although turning it negative wouldn't make any sense. So the constraint is kind of irrelevant, but yes, like that is the constraint, that you have to keep them positive so that you do not turn them negative, right? Again, like turning negative wouldn't actually help you in any way. So again, like no such rule. Anyways, max two numbers and their difference is the answer. I don't think so. Maybe the test cases are weak. Anyways, let's consider two numbers, right? Let's consider two numbers and start with this. So, and assume A is greater than B. A is greater than equal to B, right? So what are we doing? We are doing A minus B, right? We are doing A minus B multiple times. After this again A minus B, A minus B. How many times we are doing this? As long as A is greater than B. We are doing this A minus B multiple times as long as A is greater than B. What does this essentially mean? You are dividing 7 with, you are doing 7 and 2 with 7 and 2. So you are doing 7 minus 2, that is 5, 5 minus 2 again, 3, 3 minus 2 again, 1. Now you stop. So what essentially you have done is you have divided 7 with 2 and you are left with the remainder, right? You have divided 7 with 2 and you are left with the remainder. So basically when we take A and B and we do the same with this operation multiple times, where A is greater than equal to B, we are left with B and A modulo B, the remainder when A is divided by B. And we repeat this operation again with B. As B is greater than A modulo B, we'll repeat this in a reverse way now. Like A modulo B will try to reduce B as much as possible. So this is exactly what GCD is, right? GCD, what is the recursive function of GCD? GCD A comma B, from here you call GCD B comma A modulo B. and you end up at what? You end up at the GCD comma 0. You end up at GCD comma 0. So with two numbers, with two numbers A comma B, you will end up at the GCD G comma 0. With two numbers you will end up here. With two numbers you will end up here. What about with three numbers? Again, with two numbers you end up with GCD G. With the third number C, again you end up with the GCD of the three of them, right? So GCD of G and C, and that is basically GCD of A, B and C, and so on. So for n numbers you end up at GCD of the n elements, and other all elements will be 0. So basically the question is finding the GCD of the n numbers given. So let's again, like, it's pretty simple. Let's quickly write the code for this. Okay, interesting. So int G equals to ARR0 for int I equals to 1, I less than n, I plus plus, G equals to GCD of G comma ARRI, and finally return G. That should be the code, right? So I think this works. Yep. So this is working, right? So eventually it is finding the GCD. There might be other ways. To solve this. If I start there, find the minimum difference, then all the test case pass. That should not be minimum difference. That should not be the logic. I don't think that eventually, like, maybe the test cases are weak. So I don't think the minimum difference is actually the GCD. So maybe the test cases are weak, right? So, but yeah, it should be GCD. Just think about a set of large numbers, right? You will see that it is actually going wrong. So let's go to the second problem. Okay. The second problem, again, the constraints are not that high. So it's a good question if the constraints would have been better, but again, like, we are a bit lucky here. So it is said that you are given two strings S and T. You have to find a string with the minimum length that contains both S and T as substrings. If there are multiple such strings, return the lexicographically smallest one, right? So you have to find the lexicographically smallest string that contains both S and T as substrings, right? Remember, it is substrings, right? And so A, S, D, F, G, not only the lexicographically smallest, but the first condition is the minimum length, and after that lexicographically smallest string, right? So A, S, D, G, F, for example, A, S, D, G, F, F, G, H, J. So you can have A, S, D, F, G, H, J, right? See, if you see A, S, D, F, G, F, G, this is the first string. Second string is F, G, H, J. Similarly, B, C, B, A, C, B, A, B, A, B, A. So it becomes A, B, A, C, B, A, B. So A, B, A, this part is A, B, A, and B, A, C, B, A, B. So this part. So this is the lexicographically smallest string, and also with the smallest length that contains both the strings as the substrings, right? So the question is straightforward to understand. Note one thing, the constraint is 10 to the power 3, right? The constraint is 10 to the power 3, so we are safe. So we'll do it in some way, but again, like, I'll ask you a question, or I'll ask you a advancement on this question, right? And I want to see how many of your lexicographically meaning. Lexicographically means that it should be so basically the string should be smaller, right? Smaller as in A is smaller than B, lexicographically smaller, right? Or AB is smaller than BC, or AB is smaller than AD, these things, right? So you want to print the smaller one. Okay, let's understand this. So you have two strings s1 s2. So what is the smallest string, right? What is the smallest string? First case, and let's assume that s1 should come first. So let's say s1 comes first and after that s2 comes. For now let's assume this s1 will come first and after that s2 in the string, in the final string, s1 should be a substring first and then s2 should be the substring, right? So s1 and s2 this order. So what are the cases? First is s2 is contained within s1. s2 is contained within s1. In this case, what will be the answer? What does this mean? This means that let's say s1 is ABBA and s2 is AB. So s2 is contained inside s1 only, or s2 is BB. It is contained inside s1, or s2 can be also BBA. It is contained inside s1 completely. In this case, the answer will be s1. Because s1 is the smallest string that will contain both s2 and s1 as substrings, right? Second will be s2 has overlap with s1. s2 has overlap with s1, and third is no overlap. Let's discuss the last condition first. In case of no overlap, the answer will be s1 plus s2. There is no overlap between them, so the answer will be s1 plus s2. Simple. s2 has overlap with s1. Let's understand this, right? What do we mean by overlap? It means that s1 is coming before s2, right? We are saying that s1 is coming before s2. We are saying that s1 is coming before s2. So let's say s1 is something like, let's take an example only. ASDFG, and another string is FGHJ. What do I mean by overlap? There is a suffix of s1 which is also a prefix of s2. How are they combined? Just think about it. The substrings should be there. So how will they be combined? It will be s1 plus the remaining part of s2. That is not common. Something like this they will be tried to combine, right? So it will be ASD, FG is common, and after that HJ. So we have to find what is the longest common part, what is the longest common suffix which is also a prefix for s2. What is the longest common suffix of s1 which is also a prefix for s2? This is what we need, and we'll combine that suffix or the prefix portion together into one, and the remaining part will come after that. So that is how we can combine, right? So okay, so this is the logic again. If we are keeping s1 before s2, let's say there is a method called compute. There is a method called compute that will find the answer, but s1 should be first. S1 should come before s2. So first thing, it will check if s2 is in s1. Second thing, if overlap, if the longest common, s1 is first, so the suffix of s1, right? Longest common suffix of s1, that is prefix of s2, and combine them. And third is s1 plus s2. And now you can do the same thing with s2 s1. You can just call this method. So let's say you are given two strings s and t, so you can just call compute st, and you can also call compute ts once, and you will get the lexicographically smallest answer, right? You have to maintain the lexicographically smallest answer, but this will compute all possible answers, right? So this is the solution, right? So now how to find each of them? Now this is very simple, right? With the constraint given, so we can have a n square logic, because 10 to the power 3 is given to us, the length of the strings, so we can have a n square logic. So with n square logic, it is very simple to check if a string is within a string. It is easy. Second is, what is the longest common suffix, which is also a prefix. This is also easy to check, like you will check for every suffix and prefix, you will try to generate them and will check if they are equal, and if they are equal you will update the answer. So it's just writing the, is this possible? Okay, now comes the important question, right? And also, like Matthew, this will make things clear. If the constraint was 10 to the power 5, if the constraint was 10 to the power 5 or 10 to the power 6, how would you solve this? If the constraint was 10 to the power 5 or 10 to the power 6, how would you solve this? There is no need of DP here. It is just a simple ad hoc problem. You just have to compute the answer. But if the constraint was 10 to the power 5 or 10 to the power 6, how would you solve this? Anyone? Very good. We would use the KMP. In KMP, if you remember again, what is the crux of KMP? It helps us compute the LPS, longest prefix suffix. So in KMP, we compute the LPS on the same string itself. But here we have to just compute the LPS across two strings, like suffix of one string and prefix of one string. And that should not be any different, right? You are just running two pointers in different strings. So this will reduce the total algorithm to order of n using the LPS, right? This will reduce the algorithm to order of n, because finding whether a substring is a part of a string, whether a string is a substring of its of another string, that can be done using KMP easily, like string searching, normal string searching. And second is longest prefix, which is also a suffix, again a KMP, right? Or LPS. Basically the part of KMP is LPS, longest prefix suffix. So this could be the solution, but again, like we don't need to go into this complexity, so we can write a brute force way as well, n squared way as well. So let's do the n squared way only, right? So let's try to do that. So string answer, so this will be storing the answer, right? Let me just keep this aside. Okay, this will just store the answer. Okay, first thing that we need is void update answer. We don't want to mutate the answer directly. We want to be mutating it in a controlled fashion, because we want the lowest length. First condition is, okay, let me write new answer. Okay, first condition we have to keep in mind. Let's write it down. First condition is lowest length. Second is lexicographically smaller, right? So lowest length and lexicographically smaller, right? So if the current answer right now is empty, that is no answer has been found yet, so we'll just initialize this to new answer. Else if answer dot length, the current answer dot length is lesser than the new answer dot length, that is we already have a better answer, right? So it should be size, or length method is also there, but again size, answer dot size is less than new answer dot size. That means our current size is already better, and new answer is not that good, like the size is more. So in that case we'll not do anything, return. Else if new answer dot size is less than answer dot size, that means the sizes are same. So in that case answer equals to new answer. Sorry, new answer is a better size. So first priority will give to the length, right? So as the size is lesser, we'll give priority to the length. Else if answer, otherwise if when it comes here it will be of equal size, in that case we want the lexicographically smaller one. So if answer is greater than new answer, simple, answer is greater than new answer, answer equals to new answer. So that basically will take care of our update answer, right? Now let's write a code to compute. So void compute. Also, let's write a utility method bool is inside or is inside is okay, is inside. So string A and string B. So is string B inside string A? Simple, right? What does this return? Is string B inside string A, right? Is string B inside string A. So how do we compute this? We'll just go for all the starting positions. I equals to 0, I less than a dot size I plus plus. Okay, for bool present initially is equals to true. For int j equals to j equals to 0, j less than b dot size, j plus plus. First thing we'll check it is not out of index. So if I plus j is greater than equal to a dot size, present equals to false, and break. So present equals to false and break. Else if line 23, I've missed something. Oh, okay, sorry, thank you. So else if it is not equal, right? If a of I is not equals to b of j, so rather a of I plus j, not a of I plus j is not equals to b of j. In that case, present equals to false and break. Otherwise, it will continue, and if present, return true immediately. Otherwise, return false. Right. So void compute. Let's come inside this method. So void compute string A, string B. Right. First is, so A comes before B. So it will be A plus B. A comes before B, right? First is, let's initialize our answer with A plus B. So update answer A plus B. We'll initialize with this. After that, what we'll do is inside. So if is inside A comma B, in that case, update answer A. So B is completely inside A, so the answer should be A, right? Update answer A. Else or otherwise, what we'll do? Else, okay. String, okay. For now, we want to check the longest prefix, which is also a suffix, right? Or the longest suffix, which is a prefix of the second string. So what we are checking here? Longest suffix of A, which is a prefix of B, right? So that is what we are checking. So for int I equals to A dot size minus 1, I greater than equal to 0, I minus minus. Okay, so int int n, the size of the common substring will be, what we are aiming for is A dot size minus I. That is, we are telling that we are trying to see if there is a prefix of length n, which is also a suffix, or a suffix of length n for A, which is also a prefix, right? That is what we are trying to see. So string suffix is equals to A dot substr, A dot substr from I to the end. So I should do string prefix equals to A dot substr, A dot substring. What is the length? N, from 0 to n. That is the length of the length of the prefix and the suffix that we are aiming for. So this, if suffix equals to prefix, right? If suffix is equals to prefix, so in that case, answer will be what? String answer equals to update answer with a plus b dot substr. So we'll take from nth character, right? First n characters are gone, from the nth character we'll take. So b dot substr n, and that should be it. So first thing we'll do is compute s comma t, compute t comma s, and return answer. That should do the trick. So let's try to run this. Let's try to run this. Gigabot, okay. A dot size minus 1 I greater than equal to 0, I minus 1 n equals to a dot size substr I to, let's write the ending position as well, I to a dot size, and prefix and suffix equals to prefix. Okay, let's see this first. I equals to 0, I less than, j equals to 0, j less than b dot size, j plus plus. If I plus j is greater than equal to a dot size, present equals to false, break. If a of I plus j not equals to, okay, so it should be within now. So I plus j is not equals to b of j, then present false, break. 59 should be, oh, b dot substr, sorry, b dot substr 0 to n, and b dot substr n to b dot size. So let's see if this runs. Okay, so we are getting the answer correctly. So let's try to submit this. What about no overlap case? It is already taken care of here, right? No overlap case is already taken care of here. A plus b. So we are computing for both st and ts. So lexicographically smaller also it's taken care of. Like it will be a plus b, ab and ba. That is also done. Line 59 b dot substr. Yes, that is that I've corrected. So this is working fine, right? So this is the solution for the second problem. Does this make sense? It's just more like implementation, and as the constraints are less, you don't even have to do KMP like LPS. So yeah, this is like a much easier version. In case you want to see the code quickly. Cool. Let's go to the last problem. This is a bit tricky questions. Not tricky, it's more like observation based. So let's try to do this, right? So target grid sum. So what it tells is you are given a grid, n rows and m columns. The values in each cell of the grid are either 1 or minus 1. Initially you are at point 0 0, and so all the values of the grid will be all the values of the grid will be 1 and minus 1 only. So initially you are at 0 0, and you are to reach the point n minus 1 m minus 1. You can move one cell down and one cell right at any point of time. Your task is to determine if it is possible to move in such a way that the sum of the values that you've taken is k. Right? Sum of the values that you've taken is the sum of the values is k. Right? So you are given a grid of n rows and m columns, and again like 1 minus 1 is there. You are to move from 0 0 to n minus 1 m minus 1, and you can move one cell to the right or one cell to the down. You have to see if the sum of the values that you take in the path they sum up to k, right? So that's the question. And for example, you're given a grid like this: 1 minus 1 minus 1 1 1 minus 1 minus 1 minus 1 1, and you have to take k equals to 3. So you can take this path like 1 2 3 like this, and you can get the total value, right? So of 3. Okay, so let's understand this. and you have to output if it is possible 1 and 0. Okay, if it is not possible, output 0. Okay, so let's understand this, right? And this is a bit, again, like this is a bit observation based, so I'll try to explain my best. Okay, okay, so you are given a grid, right? Let's start with the smallest version of the grid possible, that is 1, a 2 cross 2, or 1 cross 1 is also possible, but let's start with the 2 cross 2, right? So 1 1 1 1 1 minus 1, let's say this is the grid, or take any other grid, right? 1 1 minus 1 1. So in this case, what are the possible values that you can get in the path, in a path from top left to bottom right? What are the possible values that you can get? You can get a value of 1 2 3. You can get a value of 1 minus 1 1, that is 1. Like consider any grid, right? So even like 1 minus 1 1 1 minus 1. In this case also you can get a value of minus 1 1 0 minus 1, and again 0 here as well, and minus 2, let's say here it is there, so minus 1 minus 1 minus 3, right? So if you see, you get these values, right? So again, like if you have n rows and m columns, the number of cells, let's say all the cells have 1, just assume all the cells have 1, so the total sum you can accumulate is n plus m minus 1 always. Right? The total sum you can accumulate is n plus m minus 1. Just see again, let's say all the cells are 1 1 2 3, n plus m minus 1, 1 2 3, right? So the total sum you can always accumulate is n plus m minus 1 if all the cells have a value of 1 from top left to bottom right. This actually throws a very important confusion to us, that is, if the parity, that is if the value required for k is even and n plus m is also even, then it is not possible. Why? Because the maximum, the value that we can get is always the other parity of n plus m, because we only have plus 1 and minus 1. So if n plus m is even, our answered the possible values can only be odd, because we only have plus 1 and minus 1. So we do not have a 0, right? So the possible values can only be odd. Again, if n plus m is odd, we can have possible values only even. Let's take a case for this as well. So let's say we have a 3 cross 3 grid, or 3 cross 2. So 1 1 1 1 1 1 1 2 3 4, we get n plus m. Let's say add a few minus 1s here and there, right? Minus 1 minus 1. So we get 1 2 3 4 1 0 minus 1 0 0 1 0 1 2 2. See, only the positive numbers are getting generated. Only the positive numbers are getting generated. So not the positive, sorry. Only the even numbers are getting generated, and n plus m is odd. N plus m is odd. So basically this brings us to the first condition that we must write, that is, if n plus m modulo 2 is same as k modulo 2, in that case our answer will be 0. We cannot have an answer in that case. Now let's come to the how do we solve the problem. So basically the solution is pretty simple. It's pretty simple. The idea is, if the mean value and the max value that you can generate from the grid, k lies within this range. If k lies within the range of mean value to max value, you can always generate k. You can always generate k, provided it is of the same parity. It is of the same parity, right? Let's take an example, right? So let's say 1 1 minus 1 1 minus 1 1. So let's say here, what are the things that we can generate? See, what is the minimum? Minimum is 1 0 minus 1 0. minimum is 0 that we can generate, maximum is 1, 2, 3, 4. So I am saying that from 0 to 4, all even numbers can be generated. That is 0, 2, 4, everything. Let's see, 4, 0 we have already made 2, 1, 0, 1, 2. Like this, 1, 0, 1, 2. You can generate 2 as well. Okay, let's take a better grid. Right, let's take a better grid. So let's say it is 1, 1, 1, 1, minus 1, minus 1, 1, minus 1, 1. Okay, what is the minimum number that we can generate? Let's see. 1, 2, 1, 0, 1. Minimum number we can generate is 1. Maximum 1, 2, 3, 2, 3. So 3. So from 1, okay, 1 to 3 only we can generate this. We cannot generate any other thing. We cannot generate any other thing. So if we see any other path, right? 1, 2, 1, 2, 1, 0, 1. 1, 2, 3, 2, 3. So we always end up at 3 or 1. We cannot generate any other thing, right? Just take any other path, right? So again, like let's take another grid, for example, just to prove our hypothesis. Is there a better grid given here? 1, minus 1, minus 1, 1, 1, minus 1. Okay, so 1, minus 1, minus 1, 1, minus 1, minus 1, 1, 1, minus 1, minus 1, 1, minus 1. Let's say this. Okay, what are the numbers we can generate? 1, 0, minus 1, minus 2, minus 3. We can generate minus 3 minimum, maximum 1, 2, 3, 4, 3. 1, 2, 3, 4. 1, 2, 3, 4, 3. So 3. So we are saying that all the odd numbers in this range will be generated. So minus 3, minus 1, 1, 3, all of them can be generated. Let's see. 1. So let's try for minus 1. 1, 0, 1, 0, minus 1. So 1, 0, 1, 0, minus 1. Minus 1 is generated. Let's check for 1. 1, 2, sorry, 1, 0, 1, 2, 1. So 1 is also generated. So we see that we can generate all the numbers from in this range, right? So basically now it is very simple, right? Now this has reduced to a very simple question. Anything else is remaining? Okay. Yeah, I think that should be it. So now it's very simple. We have seen that, again, the first thing, so parity of k and n plus m cannot be same. The parity of k and n plus m cannot be same. This is the first condition we have seen. Second is the mean value possible. Mean value possible should be less than equal to k, should be less than equal to max value possible. In this case, the answer is true, otherwise it is false. Right? So you have to find what is the minimum value and the maximum value possible. Now that can be easily done using DP. So we already know, like, we are only allowed left and downward moves, right? So right and downward moves. So we already know a DP for this. DP ij is equals to, for minimum we do something like this, minimum of dp I plus 1j or dp ij plus 1 plus arr ij, right? And for max we do the other way around. So dp max ij is equals to the max of similar thing, right? So we already know the dp to calculate the minimum and the maximum, so we'll just find the minimum and the maximum, and if k lies between the minimum and maximum, we are sure that k can be generated, right? Provided the parity is same. So Let's try to write the code for this. Vector int grid. So okay, int min dp, or let's call it dp1. First of all, n and m, n equals to grid dot size, int m equals to grid 0 dot size. So in dp1 nm and int dp2 nm. Okay, so dp1 and dp2 are done. So for again dp1 n minus 1 m minus 1 equals to the value at that position grid n minus 1 m minus 1, and dp2 as well, and this is also equals to dp2. So let's write it in a single statement only, equals to dp2 n minus 1 m minus 1, right? Now let's write the dp. So for int I equals to n minus 1, I greater than equal to 0, I minus minus. For int j equals to m minus 1, j greater than equal to 0, j minus minus. Okay, let's do plus 1 plus 1. So plus 1 plus 1. Let's do it something like this, plus 1 and plus 1. So that would make things a bit simpler for us to code. So basically we are padding a set of zeros and zeros to the right and the down, so that it never goes out of index, right? So let's make them to be 0 0, right? So for let's add two more conditions. For int I equals to 0, I less than equal to n, I plus plus. So it is grid I m, grid I m equals to 0, and for int j equals to 0, j less than equal to n, not grid, sorry, dp1 dp2, dp1 equals to dp2 im equals to 0, and j less than equal to m, j plus plus dp1 ni is equals to dp2 ni equals to 0. So for int j equals to m minus 1, j greater than equal to 0, in that case dp ij equals to min dp1 ij, sorry, dp1 should be the minimum, dp1 ij should be the min of dp1 I plus 1 j, dp1 I j plus 1 plus grid ij. Similarly, dp2 ij is equals to max of dp2 I plus 1 j, dp2 I j plus 1 plus, or rather Pahar plus 1 grid ij. So we have this, and now let's see if abs k ampersand 1 is equals to n plus m ampersand 1, their parity is same, so return false. Else if dp1 0 0 is less than equal to k and dp2 0 0 is greater than equal to k, return true, otherwise return false. So that should be the code. Let's try to run this. Isn't this increasing the time complexity? What is the complexity? It is 10 to the power 3, so its total complexity is 10 to the power 6, right? So it is just doing a 2D loop. So it's 10 to the power 6, which is okay, right? There was some issue. I forgot to check. Okay, there was some loop issue, I believe. For int j equals to m minus 1, j greater than equal to 0, j minus minus, and j equals to 0, j plus plus, n j, and nj. That should be it. So let's. Okay, so we get 1. So if that's output, but let's see. Okay, why does it not work? 3 3, and we have 4. Does this not work? 3 3 is 6, and 4, it should be 0. Anyways, why? Okay, let's see. N plus m. 3 3. This should have been satisfied, right? Let's write modulo only. ABSK modulo 2 is equals to n plus m modulo 2. Weird. Should have been 0. Let's copy this case and try to run it locally. My output. Zero. Now it's coming. So let's submit. Why use DP if just done by DFS and taking flag and current sum? Again, why 5 plus 3? 5, 6, 7, 8. Okay, so 5, 6, 7, 8, 3 parity is different, so it might be possible, but we are saying that 3 is not possible because it is not within the range. Let's see the minimum and the maximum. Min dp ij. Oh, initially everything is 0. We have to initialize with different numbers. Okay. Actually, we'll keep it to be the minimum possible number because we are using min and max, right? So min, it should be replaced. So it should be int max and it should be int min. 0 is causing problem, right? Because it should be replaced. By default, it should be replaced. So that should be there. Anyways, let's see my output. Now it is coming 1 and it should be 0, right? Expected output is 0. Okay, let's see. 0. So let's see what exactly is the problem. N plus 1 m plus 1 dp n plus 1 m plus 1 dp 1 im is int max, dp 1 so that's the mistake, right? dp1 im equals to int max, dp2 ni or sorry im should be equals to int min, so that it is replaced. Same here. dp1 nj, I believe nj is equals to int max, dp2 nj is equals to int min. So let's now run this. My output. So now it is coming 0, so this should be fine. Let's see. Okay, he's also not passing still. 2 3 0. K is 0. Isn't this the sample case? 2 3. Okay, we can actually debug this quickly. Let's see. So we have 2 3 minus 1 minus 1 1 minus 1 minus 1 1. So what is the minimum value? 1. Minimum value will be 1 minus 1, that is 0, minus 1 minus 1, and plus 1 0. Maximum value will be sorry, what is my output here? My output is 0 for some reason. Let's see. Okay, 0, 3 plus 2 is 5. So parity is not same. Let's print as well. Here, cout dp1 0 0 dp2 0 0 endl. So let's run this. Let's see what is the maximum and minimum value that we have got. So our output is way off. Our output is way off. 1 second. dp1 is minimum. dp1 is minimum. dp1 ij plus j plus 1 plus grid ij. Okay. And initially it is int max. im is int max and dp2 is int min. dp1 nj is int max, that's true, and dp2 nj is int min. Okay, that's also true, and dp1 ij is the maximum of dp1 I plus 1j dp1 ij plus 1 plus grid ij. The minimum, okay, plus grid ij, that will cause the problem. So for the first row, okay, let's not do it like this. Let's compute for the first row directly, right? So first row, last row, last column and the last row, let's compute them directly. So plus is causing problem basically. So for grid, dp1 n minus 1 m minus 1 is equals to dp2 n minus 1 m minus 1 equals to grid n minus 1 m minus 1, right? So for int I equals to n minus 2 I greater than equal to 0 I minus minus dp1 I m minus 1 is equals to dp1 I plus 1 m minus 1 plus grid I m minus 1 dp2 I m minus 1 is equals to dp2 I plus 1 plus grid I plus 1 m minus 1. Similarly for the other way around for m as well. For int I equals to m minus 2 I greater than equal to 0 I minus 1 dp1 I n minus 1 equals to dp1 n minus 1 I plus 1 n minus 1 I plus 1 I plus 1 n minus 1 I plus 1 n minus 1 I plus 1 n minus 1. So okay, where is the entire dp? Anyways, let's write it again. For int I equals to n minus 2 I greater than equal to 0 I minus minus. For int j equals to m minus 2 j greater than equal to 0 j minus minus dp1 ij equals to max min dp1 I plus 1 j dp1 I j plus 1 plus grid ij dp2 ij, or we can copy this entire thing. So sorry, copy this entire thing, and dp2, let's just replace dp1 with dp2, dp2, dp2. Okay, so let's output this now. My output 220. Why is this coming 2 again? dp1 only one path is remaining, that's true, and it should be the minimum of I plus 1 ij plus 1 plus grid ij, and dp2 ij should be the minimum, should be the maximum of still somehow it's missing number from. Okay, so I'm messing up with the dp solution somehow. dp1 n minus 1 m minus 1 is equals to n minus 2 n minus 1 m minus 1 equals to grid I equals to n minus 2 I greater than equal to 0 I minus 1. dp1 I m minus 1 is dp1 I plus 1 m minus 1 I plus 1 m minus 1, so previous plus m minus 1, and grid I m minus 1. dp2 I m minus 1 is dp2 I plus 1 m minus 1 plus grid I plus 1 m minus 1. So grid I plus 1, why I plus m1 m minus 1, I m minus 1, and here also n minus 1 I and n minus 1 I. dp2 n minus 1 I plus 1 grid n minus 1 I, dp2 n minus 1 I plus 1 plus grid n minus 1 I, and that should be equals to I. M minus 2. So sorry, let's run this now. Okay, 0 to 1, now it is coming fine, so I think the dp is working now. So this should work now, let's see. Okay, now this is working. So this was the solution again, like pretty simple dp. It's a very like common dp problem, but again like I screwed up with the implementation a bit, but yeah, like finding the maximum path in a grid or finding the minimum path of a grid, that's pretty simple straightforward dp. So that was the solution. Like if you have within the sum, like within k, then you can always make it, otherwise you cannot make it. Cool. So that should be today's, like that should be all for today. So thank you guys for joining in, and yeah, I'll be seeing you next Sunday.